Have you ever wondered if it's possible to build machines so tiny they could move within our cells? Welcome to the fascinating world of nanorobotics, a realm where science fiction meets reality. Nanorobotics is a convergence of nanotechnology and robotics, creating machines so minuscule they measure just a few billionths of a meter. To give you a sense of scale, a nanorobot is approximately 1,000 times smaller than a human hair. This exciting field holds the potential to revolutionize many aspects of our lives. Imagine tiny robots that could navigate our bodies, diagnosing diseases or delivering targeted treatments directly to unhealthy cells. But it's not just about medicine. Nanorobots could also be used for environmental cleanup, repairing damaged infrastructure, or even constructing microscopic electronic devices. The possibilities are as vast as the universe, and as tiny as an atom. As we delve deeper, prepare to be amazed by the world of nanorobotics. At its core, nanorobotics is the fusion of robotics and nanotechnology. To fully grasp nanorobotics, we must first take a step back and understand nanotechnology. This field of science deals with the manipulation of matter at an atomic and molecular scale. Imagine a world so small where a single strand of human hair is equivalent to a skyscraper. That's the world we're dealing with in nanotechnology. It's like being a master sculptor, but instead of chiseling away at marble, you're shaping atoms. Now, when we apply this to robotics, we venture into the realm of nanorobotics. Here, we're building robots so tiny they're measured in nanometers. To give you an idea of how small that is, a nanometer is 1/1000th of a meter. Yes, you heard that right, 1/1000th. So, what does a nanorobot look like? Well, at this stage, they're relatively simple. Some are designed like propellers, others like tubes, but all are crafted to perform specific tasks at a microscopic level. A good example of a simple nanorobot is a DNA origami robot. These are tiny devices made from strands of DNA that can walk, turn, and even pick up molecules. Now I know what you're thinking. This sounds like something straight out of a science fiction novel. But believe me, it's not. Scientists and engineers across the globe are already using nanorobots for a myriad of applications. Think about it. These tiny machines can go places and do things that were once thought impossible. They can swim through your bloodstream, delivering drugs directly to cancer cells. They can repair damaged tissues from the inside. They can even help us understand the inner workings of our own cells. So, nanorobots are not just science fiction, they are real, and they are here. Their potential is vast, and we're only just beginning to scratch the surface. But one thing is certain, the fusion of robotics and nanotechnology is opening up a whole new world of possibilities. You might be wondering, how do these microscopic machines operate? Well, let's journey into the intricate world of nanorobots to find out. The operation of nanorobots is an exquisite blend of physics, engineering, and biology. They're so tiny, about 1,000 times smaller than the width of a human hair, that they operate in a realm where conventional rules of motion don't apply. Instead, they navigate through a world dominated by viscous forces, similar to a human trying to swim through honey. Powering these tiny machines is another challenge. Given their size, they can't carry conventional batteries. So, how do they get their energy? Some nanorobots rely on external power sources like magnetic fields or light. Others harness chemical reactions to power themselves. For example, some nanorobots use glucose, a type of sugar in our body, as a fuel source. But what about control? How do we tell these tiny machines what to do? Well, some nanorobots are designed to respond to specific stimuli in their environment, like changes in temperature or chemical concentration. This is a form of autonomous control, where the nanorobot carries out its task based on pre-programmed responses. On the other hand, some nanorobots can be remotely controlled using magnetic fields or light signals. This gives scientists a high degree of control, allowing them to direct nanorobots with precision. And when it comes to performing tasks, nanorobots can do a surprising amount. They can manipulate individual molecules, deliver drugs to specific cells, or even repair damaged tissues at a microscopic level. However, designing and operating nanorobots is not without its challenges. Their tiny size makes them difficult to manufacture and control, and the human body is a complex and unpredictable environment. But scientists are making progress, developing new techniques and technologies to overcome these challenges. So that's how these tiny robots operate, overcoming challenges and pushing the boundaries of what's possible. The potential applications of nanorobotics are as vast as the universe itself. As we delve deeper into this captivating field, we discover that these tiny machines have the potential to revolutionize various sectors of society. Let's start with medicine. Imagine a world where surgeries are non-invasive and treatments are targeted directly at the cellular level. This isn't a science fiction plot but a reality that nanorobots could bring. They could be programmed to perform tasks such as precise drug delivery, cellular repair, and even the destruction of cancer cells. The ability to intervene at such a microscopic level could drastically reduce side effects and recovery times, changing the face of healthcare as we know it. Next, let's consider environmental control. The potential for nanorobots in this field is equally astounding. They could be employed to break down harmful pollutants in the air, water, and soil, effectively cleaning up our environment. Nanorobots could even be used to monitor ecosystems, providing real-time data on pollution levels, climate change, and biodiversity. This could enable us to respond more effectively to environmental crises and help preserve our planet for future generations. The manufacturing sector, too, stands to benefit from nanorobotics. Nanorobots could be employed to construct materials at the atomic level, leading to products with unprecedented precision and quality. They could also help to create new materials with properties that are currently unattainable. This could revolutionize industries ranging from electronics to aerospace, opening up new possibilities for innovation and advancement. These are just a few examples of the real-world applications of nanorobotics. The possibilities are virtually limitless. As this field continues to advance, we can expect to see nanorobots becoming an integral part of our lives, quietly working behind the scenes to make our world a better place. From curing diseases to cleaning up the environment, nanorobots could be the heroes of the future. As we continue to unlock the potential of these tiny machines, we may well be on the cusp of a new era in human history. The future of nanorobotics is not only exciting but also holds the promise of truly transformative changes. Imagine a world where minuscule robots, invisible to the naked eye, patrol our bodies, fixing damaged cells and fighting off infections. Or consider nanobots deployed in our environment, cleaning up pollution or repairing infrastructure at a microscopic level. These scenarios may sound like science fiction, but they're part of the potential future landscape of nanorobotics. Ongoing research in the field is pushing the boundaries of what's possible. Scientists are exploring ways to improve the design and control of nanorobots to make them more efficient and precise. There are also efforts to develop new applications, from medical treatments to environmental solutions and beyond. The potential impact on society is enormous. In healthcare, nanorobots could revolutionize how we diagnose and treat diseases, potentially leading to cures for conditions that are currently incurable. In the environment, nanorobots could help us to tackle pollution and climate change by cleaning up harmful substances or even capturing carbon dioxide from the air. But with these exciting prospects come significant challenges. One of the biggest is how to power nanorobots. Traditional power sources are too large and inefficient, so researchers are exploring innovative solutions, such as using the body's own energy or harnessing environmental forces. There's also the question of how to control nanorobots, to ensure they carry out their tasks effectively without causing unintended harm. Furthermore, there are ethical and societal issues to consider. How do we ensure that nanorobotics is used responsibly and that its benefits are accessible to all? How do we protect privacy when nanorobots could potentially gather sensitive information? These are complex questions that require thoughtful discussion and robust regulatory frameworks. In spite of these hurdles, the future of nanorobotics looks bright. Advances in technology and our understanding of the nanoscale world are opening up new possibilities every day. And while there's still a long way to go, the progress made so far is encouraging. While the journey is filled with challenges, the potential rewards make nanorobotics a field truly worth watching. We've journeyed through the world of nanorobotics, from its theory to its applications and future. We've delved into the microscopic realm, discovering how these tiny machines operate. By manipulating individual atoms and molecules, nanorobots can perform tasks on a scale that was once unthinkable. We've also explored the vast potential applications of nanorobotics, from medicine, where they can target and destroy cancer cells, to environmental science, where they can clean up pollutants. Nanorobots hold the promise to revolutionize many fields. Looking to the future, we've imagined a world where nanorobots could become an integral part of our daily lives. As the technology continues to advance, these tiny machines could reshape our world in ways we can only begin to imagine. So the next time you think of robotics, remember, the future may not be as large as you imagine, but as small as a nanorobot.
Please do like, share and subscribe to my channel. Thanks for watching.